I know we went through a lot of information in the last video, so we're going to work through a couple examples together. This first one is wanting us to find all 6 trig ratios again. So it says theta is formed by a segment through the point -3, 4. So for starters, graph the point -3, 4. And what it's talking about is you have a segment going through that point, and this is the value of theta. So that lets you know about what you have going on. And what we would need to do is we would need to say that we're actually going to create our triangle by dropping this down to the x-axis. Always drop to the x-axis. And then I'm going to go ahead, and if this value here is the point -3, 4, it is true that this side of the triangle I can regard as 4, and this I can regard as -3. And then I can figure out this missing side of the triangle using Pythagorean theorem. Pythagorean theorem, I would have 4 squared plus 3 squared equals c squared. And you might ask why I didn't write down the -3. Well, if I wrote down the negative, I was going to square it, and it was going to become a positive anyway. So now I get 25 as c squared, and c equals 5. Now at this point, it's really your choice whether you want to think in terms of opposite and adjacent, or if you want to think in terms of x and y, because it's going to be the same thing. Because, for example, for sine of theta, I'm going to have the opposite over the hypotenuse. So if I think opposite over hypotenuse, it's 4 over 5. Or if I think the y-coordinate over my radius, the distance to this point from the center, which is the same thing as my hypotenuse, you can think of that as your hypotenuse or your radius of a circle. Basically, that segment helps to form. But anyway, in either case, you're going to have a 4 over 5, whether you think opposite over hypotenuse or y over your radius. Then if you keep going, you're going to have your cosine of theta. You can think of that as adjacent over hypotenuse, so that would be -3 over 5. Or you can think of it as the x-coordinate was -3 over my radius of 5. Either way, you get the same thing. Tangent of theta, if you think opposite over adjacent, you're thinking 4 over -3, which is -4/3. And if you're thinking the y-coordinate or the x-coordinate, once again, 4 over -3, same thing. The reciprocal trig functions, remember, just flip these trig functions you have upside down. So the co's go with the no co's again. So that's 5 over 4. Cosine had a co, so you need secant, which doesn't have a co. And that's -5 over 3. I usually leave the negatives on top. That's customary when you're doing the reciprocal. And then cotangent of theta equals a -3 over 4. Because if I were to flip that to like 3 over -4, if I simplify that, I would generally just move the negative to the top anyway. So that is the preferred form with the negative on top, but the other numbers flip. We'll do a couple more examples in the next video. I hope you're starting to catch on to this.